We've already looked at proportions and pretty much looked at some fairly straightforward ones, and now we're going to look at some little more detailed examples, and we're going to solve them using cross products. So what is a cross product? Well, it's the product of the numerator of one ratio and then the denominator of the other ratio in a proportion. So we have this example where we have 4 over 5 is equal to 8 over 10, and of course you probably recognize right away that if you just simplify 8/10, you'll get 4/5. So we know these two are indeed equal. The idea is to multiply across the equal sign, and please do this only when you have an equal sign between two fractions or two ratios. So if we take 4 times 10, that one diagonal, this will be equal to the other diagonal, so going across the equal sign in the other direction, 5 times 8. Okay, and of course 4 times 10 is 40, 5 times 8 is 40. Now if you see these ratios written with a colon, so 4 to 5 is equal to 8 to 10, these two numbers that are on the inside we refer to as the means. Those are the two that are next to the equal sign. And then the two outer numbers away from the equal sign are the extremes. So if you have ratios represented in this form, then we'll take the product of the means and set that equal to the product of the extremes. Okay, one place that we're going to use proportions is when we're looking at scale. So first of all, we can have a scale drawing, and this is a two-dimensional drawing of an object, and in this drawing, we're going to have the dimensions of the drawing are proportional to the dimensions of the object. A scale model is very similar, except that it's a three-dimensional model. But again, the dimensions of the model are in proportion to the dimensions of the object. And so we can use proportions to solve some of these scale problems. And of course, the idea of scale is simply the relation between the drawings or the model's dimensions and the actual dimensions. So we'll see some examples here in just a moment. Okay, so first of all, let's start with a fairly straightforward proportion where we have 6 over x is equal to 3 over 5. Okay, and we're going to use the idea of cross products, so we can say 6 times 5 is equal to x times 3, which of course we can write as 3x. So if we want to simplify this, we have 30 is equal to 3x, and then of course we'll get our solution by dividing by 3. So divide by 3, divide by 3, and we get 10 is equal to x. And to check that, we can substitute 10 back in place of x. So we have 6 over 10. Does that equal 3 over 5? And of course you can check this a couple ways. If you multiply 3 times 2, you get 6. Multiply 5 times 2, you get 10. So that checks. We can also double check using our cross multiplication. 6 times 5. And does that equal 10 times 3? And of course 6 times 5 is 30. 10 times 3 is 30. And so it checks. Okay, number 2. Similar idea here. 3 over 10 equal to 12 over 5y. So we'll use our cross products here. 3 times 5y is 15y. That's going to equal 10 times 12, which is 120. And then we'll get y by itself by dividing by 15. So divide by 15. And on the left-hand side, we get y. Right-hand side, 120 divided by 15 is 8. And we can check that by looking at 3 over 10. And we're going to check, does that equal 12 over 5 times 8, which is 40. And so if we take our cross products, 3 times 40, does that equal 10 times 12? 3 times 40 is 120. 10 times 12 is also 120. And so again, this checks. Okay, number 3. Now we have something a little more complicated because we have a variable in the denominator of both fractions. And also, on the right-hand side, this denominator isn't simply x or 2x, it's a binomial, x plus 5. So we have two terms here. Still, we apply the idea of cross products. Just be careful here to put parentheses around the x plus 5 because we're multiplying 4 times that entire denominator, not just times the x. And this is equal to x times 3, which is 3x. Okay, so if we apply the distributive property, we have 4x plus 20 is equal to 3x. And I'm going to go ahead and subtract 3x from each side. Subtract 3x. And so on the left-hand side, we have x plus 20 is equal to 3x minus 3x is 0. And let me rewrite that over here. X plus 20 is equal to 0. And of course, I'm going to get x by itself by subtracting 20. So subtract 20, subtract 20, and we get x equals negative 20. We could check that by substituting negative 20 back in place here. And we'll have 4 over negative 20. Does that equal 3 over, and of course negative 20 plus 15 is negative 15. Well, we can simplify both of these fractions. 4 over negative 20 is simply negative 1 over 5. Remember, if you have a negative in a fraction, it can go in the denominator, it can go in the numerator, or it can go out front. Those are all equivalent. And then 4 over 20 simplifies to 1 over 5. And likewise, we can put our negative in front. 3 over 15 also simplifies to 1 over 5. So that checks. Number 4, same idea, cross products here. Notice we have a binomial in each of these denominators. So we have 4 times 2x plus 4 is going to equal, and we can write x minus 3 times 3, or we can reverse the order and make it 3 times x minus 3. Either way, remember, multiplication is commutative. We can put these terms in either order. So here 4 times 2x is 8x, 4 times 4 is 16, and that's going to equal 3x, and then 3 times negative 3, negative 9. Okay, I'm going to subtract 3x from each side, so we get all of our x's to one side. And we have 5x, still have 16, is equal to, and the x's cancel out, now we have negative 9. And let me rewrite that here. 5x plus 16 equals negative 9. So we have the x's over here. That means I want to move all the numbers to the other side. So I'm going to undo the addition first by subtracting. Negative 16 here, subtract 16. So we still have 5x equals, and negative 9 minus 16, we're getting even more negative, will be negative 25. And then finally divide by 5. Okay, so we get x is equal to negative 5. And if we substitute negative 5 back in here, we'll have 4 over negative 5 minus 3 is negative 8. Does that equal 3 over 2 times negative 5 is negative 10, plus 4 is negative 6. And once again, we can simplify these. This is negative 1/2, which is equal to, likewise here we have negative 1/2, so it checks. Alright, number 5. We have a recipe that yields 12 buttermilk biscuits, calls for 2 cups of flour. How much flour is needed to make 30 biscuits? So we could set this up a couple ways. Let's look at the ratio of biscuits to flour. So we have 12 biscuits to 2 cups of flour will equal Let's see, in the second case we have 30 biscuits to, we don't know how many cups of flour, so let's say X. Okay, so notice the units match up: biscuits to cups of flour, biscuits to cups of flour. And that's how you can tell whether you have your ratio set up correctly. So we're going to cross multiply here, and we'll have 12x, so 12 times x equals 2 times 30 is 60, and then divide by 12. So we get x is equal to 5. And of course this is cups, so our answer is 5 cups of flour. Right, a map has a scale, so here we go with our scale. This is two-dimensional because it's a map. It has a scale of 1 centimeters to 15 kilometers. So every centimeter on the map represents 15 kilometers in the real world. Okay, what would be the actual distance represented by 0.5 centimeters on the map? So let's set up our ratio of 1 centimeter to 15 kilometers is equal to, and because we have centimeters on top here, we need centimeters on top here. So 0.5 centimeters to, let's call it d for distance. Okay, and this is the actual distance. So if we cross multiply, we get 1 times d, which is simply d. We're in luck. We don't have to do any simplifying or any multiple steps to solve for d. All we need is 15 times 0.5, which is going to be 7.5. And the units, of course, are going to be kilometers. So centimeters to kilometers, centimeters to kilometers. All right, one more, how about? Okay, here we have another scale. This time it's a three-dimensional because it's the scale model of a car. But we're really just going to be looking at one dimension. We're only going to be looking at the length here. Okay, but the scale model is 1 to 24. Notice that we don't have any dimensions here. So that means every 1 inch on the scale, on the model, represents 24 inches on the actual car. So whatever units the scale model is in, then those will be the units of the actual object. So let's look at that. 1 to 24 is going to equal, so here's the model to actual. So model 7.5, let's go ahead and write 7.5. Really don't like having fractions within a fraction. 7.5 to the actual length, x. So if we cross multiply, we got lucky again because we just have one x. So x is equal to 24 times 7.5, okay, which is equal to, let's go ahead and set that up here. So 24 times 7.5. Notice we can do this by hand, right? So we get 20, carry the 2, 2 times 5 is 10, plus 2 is 12. Start with 0, 7 times 4 is 28, and again we carry the 2. 7 times 2 is 14, plus 2 is 16. We add 0, 0, 1, 8, 1, and we have to move over one decimal place. So our answer is 180, and that's in inches because remember we have the same units as the scale model has. So this would be 180 inches. If you wanted to convert that to feet, you can do that. As it turns out, in the case of cars, they usually do talk about the length in either inches or centimeters. So good luck with your cross products, and please again remember, only apply this cross multiplying when you have an equal sign between the two ratios.